Today on Green by Design,
we're going home. Hi, welcome to Green by Design. I'm Greg.
and I'm Connie. And today we're going to kick off our Newly Greens transformation by doing some work on our house.
Now, as Newly Greens, we understand some of the negative impacts of some of our choices, but we're still trying to figure out how to incorporate the better choices into our daily routine.
That's right. And while we're doing that, our Extreme Green segment is going to feature the BASF's Near Zero Energy Home in Paterson, New Jersey. This is the second Platinum LEED certified home in the country, LEED being leadership in energy and environmental design, and they truly represent that.
And they do, and there's some really cutting-edge technology there, and we're going to kind of contrast that cutting-edge technology with some of the issues that we face in our 100-year-old Tudor.
Challenges to be sure.
To be sure. Let's start by getting extreme. I got a personal tour from Jack Armstrong, BASF's Director of Building and Construction Markets. Now, building a sustainable home is one thing, but as one might expect, there's more behind this project than just putting up some fancy new walls.
The City Council, as well as the Mayor, Mayor Torres, was really interested in working with us to try and bring a style of construction to Paterson where people that maybe don't have a whole lot of money to spend on housing can still have a great house, but also have a very energy efficient house. We used local builders, we used local electricians, local plumbers, who really weren't familiar with kind of high performance building technologies. And that way, the idea is they get to learn and see that, wow, this kind of new innovative stuff isn't all that weird and strange, and we can build with it. And gosh, we can build with it just as inexpensively as we can with other stuff.
Jack added one more interesting personal twist when he told me of BASF's decision to donate the completed home to one deserving Paterson family.
So in this particular case, it was a young boy who was riding his bicycle when he was about 8 years old here in the streets of Paterson. Unfortunately, got hit by a car and is now quadriplegic. And so he's been living away from his family for the last 6.5, 7 years. The family really didn't have the means or the conditions to bring home a quadriplegic in the size home that they had. So the idea here, besides just having the sustainable elements of an energy efficient home, we really focused on a healthy indoor air environment. We focused on the universal design throughout the house. So whether it's a quadriplegic or just a senior citizen as they're getting older, the idea of where the plug's positioned, you're not bending down so far, all those ideas in mind as kind of the seniors of today are aging.
You know, the approach to the Near Zero house is really very simple. There are three main concepts. One, they built a really airtight house using materials that retain thermal energy.
And then they outfit that house with highly efficient appliances, Energy Star rated appliances, and compact fluorescent lighting all through the house.
And the energy they do need, they offset by using some really unique solar elements. And this results in an incredibly efficient product.
Now, the reality is we're never going to come close to the overall performance of the Near Zero home with our home, but we can look to a few of those concepts just for inspiration for improvements.
Yeah.
Let's start in the dining room.
Yeah, let's go. Jack explained that the stone wall in the dining room acts as thermal mass in the house. What that means is that during the day, the wall will absorb thermal energy. And at night, it will slowly release that energy back into the house. This reduces fluctuations in temperature that could cause your furnace to cycle on using more energy. It keeps your house at a more comfortable temperature.
Now, we're not going to build any stone walls in the house, but for around $60, we can replace our old analog thermostat with a new digital one. And the philosophy is the same. Whereas the BASF house has a thermal structure that helps to conserve energy, we're going to use a programmable digital thermostat to keep the furnace from cycling on when we're not home or when we're sleeping.
Hey! That's nice.
Thank you.
All right, come on, now go fix the fridge. But before we do that, let's take a quick look at the Near Zero kitchen.
Energy Star appliances are available. So one of the key aspects to any home and the great performance and trying to get to near zero energy is certainly having these great appliances. A refrigerator from the 1970s was maybe half the size and used 3 times the energy as one like this. Whether it's in your oven or whether it's in the self-heating hot water systems, in the dishwashers, all of them actually component-wise, piece by piece, add to this different energy savings. And all the fixtures and the sinks, the shower heads, they're all the very low water efficiency flushing systems. So that has certainly an impact on the amount of energy that the house is using for hot water heating too.
In terms of the building materials here, we have like the granite countertops and the wood paneling. Was any of that procured in a sustainable way? Or is
all of the wood products are from what's called FTC certified forests, where they don't come in and clear cut the forests. They actually individually pick out the trees that are the big ones and they let the little ones there. That helps the whole ecosystem of the forest not be devastated when you take out some of the big trees.
Refrigerators are a real energy hog, and they can use up to 30% of your household electric. But here's a tip. If you check the seals and vacuum the cooling coils, you'll be in pretty good shape.
What happens is dust builds up on the cooling coils, or if you don't have adequate ventilation around your fridge, you could take up to a 10% hit on your energy efficiency. When was the last time we vacuumed this fridge, Scott?
Never.
And how long have we had it?
About 4 years. And you know, the same holds true for your freezer. You should defrost it at least once a year. I remember one time. Almost 400 pounds of carbon are released each year powering your fridge. So you should keep your fridge at 36 and your freezer at 0. You'll save 46 pounds. We're on a low-carb diet.
That's low carbon. Now, anyway, I'm not saying that it's been a while since we cleaned out the freezer, but I happen to know that this wedding cake is at least 7 years old.
Yeah. Ew. Ew.
What?
Greg, this has to go back in the freezer, you know. It's going back in the freezer. This is going back in the freezer. When we return, we'll seal the deal as we take a closer look at how the Near Zero was constructed.
And we'll follow that with a no-goods look at some great eco-animal friendly products for around the house.
You know you're not throwing that cake out, right?
There is really only one boy, one girl, one tree, one forest, one ocean, one mountain, one sky, and one simple way to care for it all. Please visit earthshare.org and learn how the world's leading environmental groups are working together under one name, EarthShare, one environment, one simple way to care for it.
Hi, and welcome back. We're taking a look at how our homes use energy, or should I say waste energy. Buildings account for 40% of all the energy used in the United States. So if we can improve our building construction, we can lessen our impact on global warming for sure.
Recently, I took a tour of the BASF Near Zero Energy home in Paterson, New Jersey. It's a great example of how to pull together a lot of different cutting-edge technologies under one roof, literally. Here's Jack Armstrong to explain.
All of the technologies that are illustrated here in the house are what we consider kind of off-the-shelf technologies. Nothing here in the house is something that a builder couldn't do, or a homeowner, or a designer, or an architect. It's just most people don't think with this big scope in mind, and little savings here and there in all the different places, at the end of the day, they add up.
When somebody is looking at a project, you know, say I'm just a homeowner who's thinking about building a more sustainable home, and I'd like to incorporate high efficiency, I'd like to do those kind of things. Obviously you guys served as the catalyst to bring all the contractors and the suppliers and all that kind of thing together. Where would the normal person who says, I want to do this, where would they start?
But in absence of just knowing who a good builder or an architect is, I would recommend that people go to the U.S. Green Building site And New Jersey actually has their own U.S. Green Building Council chapter here, and they have a great website. And it actually leads you not only to strategies that you would want to have, but as well also builders in the area that are kind of sympathetic in the products. Additionally, you can go to other resources like the Department of Energy has a program called Build America. There's another organization called Basf. And with this PATH program, they also have maybe 150 different strategies that you can choose from, that when you put them all together, you get this, the sum is worth more than the parts, this synergistic bundle. So those would be kind of my recommendations. And then also the website for this particular demonstration home, betterhomebetterplanet.com. And all of the people that gave products to this house are there with their contact information, as well as the videos of how the house was built, the photos of it going up, and just the philosophy about when you want to begin a project like this, how would you start? So I think those are some good references that people can use as kind of a primer to get them started.
The Near Zero home is a great start, and there should be a push to make construction more efficient. But the reality is most of us are going to buy an existing home. There's good news though. There are things you can do to make your home more efficient and tighter. And it doesn't have to cost a lot of money, especially if you get your friends to do it.
That's right. And my friend Damon is going to take a break from his audio engineering duties to give me a hand on the house here.
Yeah.
Con, you want to jump on audio?
No. Oh, sure. Oh.
How you doing?
Hey, what's up?
What's up, bro? How's it going?
All right.
Good.
So what are we going to do?
Well, the plan is this corner bathroom back here is really drafty. It's one of the rooms in the house where I really notice that it's significantly colder in the wintertime.
Well, I see there's a gap up at the top. We could try caulking them up and kind of see what happens from there.
All right. I mean, it definitely looks like where the stone meets the other building materials, where it hits the kind of wood tutor. There's definitely gaps everywhere where the building materials meet.
Yeah, I see it. Well, let's do some caulking.
All right.
Now, if you're taking on a caulking project, you want to start around your foundation or your bottom floor. The heat that you lose through poor insulation in the attic creates a low pressure system in the house, which sucks the cold air in through the lower floors first.
Now, I tend to go for the rubberized caulks as opposed to like the silicone or the latex, because they're going to hold up a lot better outside, but they are only an outside caulk.
You know, you could actually help me.
Now, everything we've done today, from the thermostat to the caulking, I spent less than $100 on everything.
Not including labor.
But now you're not going to renovate your entire house for less than $100. But the idea is just like our newly green steps, as we chip away a little bit at a time, to just chip away and try to improve your house a little bit at a time.
Like the way this glazing is chipping off of the window.
Speaking of windows, hey Con, you were going to spotlight some window cleaning fluid on O-Goods later. Let's have it. Thanks. I'm going to go help Damon.
BASF has an outreach program to actually build fortified homes and orphanages in Sri Lanka. So these were actually photographs of Sri Lankan children with the art that they produced, and then we had kind of a vernissage or an art auction here at the house to raise money for also the building of the school in addition to the houses. So here's a picture of the young boy making his piece of art, and then here on the wall is actually the piece of art that he made for sale.
As far as hanging the pictures on the wall, I know normally you'd be searching for a stud to drive a nail in. Are you stuck with where these pictures are? What if the homeowner wants to customize things a little bit?
That's really kind of one of the great benefits of having a structural insulated panel house, because the walls are solid walls all around you. So you don't have to get that stud finder out or be knocking on the wall to see where you're going to hang your picture, because they're actually load-bearing walls all the way around. And normally in your wall you have these 2x4s and then the fiberglass batt insulation in the middle. When you have your 2x4, that's a place where there's no insulation. And if you add up the number of 2x4 stick frame construction lumber around the house, it means your house is about 25 to 30% solid lumber. And lumber is not a very good insulator compared to insulation. So it'd be kind of like leaving two windows open in your house all the time.
Our tour then led us upstairs to the home office.
Let's go now into the storage room here, and we haven't finished the walls, and we'll be able to see some of the neat technologies in the roof and actually show what a structural insulated panel looks like. I actually have a sample here to illustrate a structural insulated panel, but here is the 8-inch thick expandable polystyrene product that provides all the insulation and the great strength in these SIP systems. And then you have the oriented strand board that's adhered on to make it actually a structural supporting element of the house. And so if you just imagine this particular sandwich right here, and up in the roof, that's more or less what's right over our head right now. So this is the roof assembly both in the walls and in the ceiling.
Now, is this actually really the same stuff that's in a styrofoam cup?
Exactly. So when you go to McDonald's and drink a styrofoam hot cup of coffee, this is what you're drinking out of.
So this is no different then?
The only difference here is this one has a flame retardant in it, where your coffee cup typically wouldn't have a flame retardant in it. So once all of these panels go together, I wanted to show you just right here on the wall, the intersection of, say, a SIPS panel. This one happens to already have gypsum board on it, or sheetrock. And so the way they come up and meet, everywhere where they meet, and of course they're nailed together and fixed, but you can see this BASF polyurethane adhesive or foam sealant, and that's actually doing a couple of things. It is helping to maintain the bond between the two members, but mainly it's stopping any air leakage or air infiltration. Secondly, you'll notice where these roof panels have come together, the gap is filled with foam, and then there's this special tape that's used to actually be an air barrier. But essentially what this does is over the next 50, 100 years, as the house moves and settles and absorbs a little bit moisture and contracts, you get movement between all the different assemblies. And so this helps maintain that very impressive air sealant and performance for the house. And this particular house was qualified by the Environmental Protection Agency's Energy Star program for houses, and they actually do a blower door test. So what they do is they close all the doors and windows, turn off the air conditioner, hook up a special front door with a fan, and they actually blow air into the house, and they're measuring the air leakage rate through all the nooks and crannies. A traditional well-built house may have an air change of, say, 5 air changes or air volumes of the house each hour. This house only has 0.5, so 0.5 air changes.
Wow.
So now you can see why it's so important on the selection of products you put in the house. So the low VOC adhesives and the sealants and the paints, because you want a real healthy indoor environment.
So the blower door test that Jack is referring to is part of an Energy Star home audit, and you can book those yourself at energystar.gov. Now, also there, they have some pretty cool online calculators that give you a pretty decent estimation of what your home energy use is. So I use those calculators to establish a baseline for us so that we can track our progress as we try to reduce our usage. So the bad news is that our home scored a 0.7 on their 1 to 10 scale. So that's pretty bad. And I'm not particularly proud of that fact, but it does give us some place to start. So using those numbers, we have set ourselves a goal of 20% improvement by 2008. That means we want to try to come in closer to a 2.3 on that scale by next year. Now that means in terms of numbers that we have to reduce our electric use by 3,700 kilowatt hours and our natural gas use by 529 therms a year. So that's kind of what we're shooting for, and we'll put links up to those calculators on our site so you can try and check it out yourself. Now let's get back to the near zero home.
One of the things I wanted to be able to show you is actually how the solar power assembly on the house is actually constructed. And we have 2.5 kilowatts of these laminated solar power mats or membranes from a company called Unisolar. And these are actually on the south-facing side of the house, and they're mounted or adhered onto an Englert kind of cool metal roof, we call it. And we call it a cool metal roof because the highly reflective coating that BASF makes and puts on the metal actually reflects the sunshine and keeps the roof cooler. So a traditional roof would maybe be about 40 degrees cool or hotter, and the BASF highly reflective coatings are able to actually reflect the sun's heat rays and keep the roof cooler. So it helps actually the temperature in your attic as well as inside your house and saves energy.
Even with a darker color.
Even with the darker colors. That's kind of the magic of the innovative pigmentation technology that's in the paints. Kind of working on this infrared level, not only on the UV and the visible light level.
Very neat.
And then here you can actually see, and it's very soft and pliable, and it actually is flexible. And then when they're laminated to the metal substrate here, you get a very strong assembly. When you walk outside and look at the roof of the house, you almost don't even realize that there's a laminated solar membrane
Yeah, you don't
onto
have
the
those
roof.
traditional solar panels.
Exactly. And typically with the standing seam metal roof, many people are bolting on the traditional solar panels. And the reason we chose not to do that here at the Near Zero Energy home in Patterson is because this way we're able to actually do two things in the same roof square footage. We have electricity being generated on top, you have the metal roof, and then underneath it on the actual roof upstairs, we have tubing of a water glycol mixture, and that's being used to heat the hot water system. So it's kind of a photoelectric on top, thermal hot water system on the bottom. And if you had a big panel here shading the roof, then the roof wouldn't get hot and you couldn't heat the hot water.
Right.
But the hot water from the roof will come down during the summer months as much as 180 degrees Fahrenheit. And in the winter, it'll preheat the water to about 80 degrees Fahrenheit.
Really?
So it really is a quite interesting system. So all in all, for the house here, we have about 2.5 kilowatts of electric, 4 kilowatts of thermal, so for a total of, what is that, 6.5 kilowatts total.
The unique solar hot water rig is accompanied by a new light deck flooring. The Near Zero uses radiant heating laid on top of this polystyrene form. The frame acts as an insulator, which improves thermal stability across floors and makes the house very quiet.
With a house this tight, it's important to circulate air. A quick look in the attic revealed a heat recovery ventilator. This exchanges inside and outside air. The fresh air from outside is first run through a HEPA filter to remove dust and allergens, but it's also treated with indoor air before it's vented. In this way, the air coming in will be closer to the temperature of the house air, so it won't rob the thermal energy.
Humidity is controlled as well, and this is important because the steam from showers and water use could build up and cause mold if it were not controlled.
We wrapped up our tour down in the basement utility room.
Well, now I'd like to show you a little bit about the kind of brain center, you might say, of all the high technology and how it comes together here in the house. Actually, what you're leaning on right here, this is the apparatus where the power comes down from the solar power panels on the roof, the 2.5 kilowatts. It comes in here. It works as an inverter, so it takes the DC power to AC. Down below, there's actually about between 8 and 10 hours worth of battery backup, so if we lose power in the house. And then whatever power we're not using in the house, this device actually manages it and allows us to sell it back to the grid.
Is it important with the, because it's such a tight house and you have to circulate this air, I would imagine you really kind of need that battery just because things would start to get stagnant?
Well, you could always open a window.
Oh, yeah.
So there's always like the good old days where you just open a window and in the event you think it feels stuffy or something like that. And now what's kind of behind me here is a big 200-gallon hot water tank. And you remember when we were up in the attic and you saw the insulated glycol tubing coming down? That actually comes in here and it's that 150, 180 degree Fahrenheit water coming in here through a closed loop circulating between this tank and the roof. And then this tank has the regular water that comes in from the utility system. That water comes over here to this smaller mixed tank. And if it's really hot from a sunny day, then you can actually dilute it down and put some cold water in, and it's all done through a thermostatic controller. So on the wall behind us there, we have a high efficiency 95% Wiesmann boiler, and it's through this tube here, we actually use the air from the outside the house, fresh air for the combustion, and then the exhaust goes out. So it's kind of a tube within a tube. So that way there's no combustion materials actually inside the house. And the other piping that we have here is actually for the radiant floor heating. So you'll see only just in this area the copper piping, and through the rest of the house it's all the cross-linked polyethylene tubing. And that's a much lower cost alternative than copper, which has gotten so expensive.
The BASF house is one great example of efficiency. But since not everybody can go out and build their own home, we thought today's edition of O-Goods should focus on more easily attainable sustainables for inside your home or apartment. These are things that will keep your air and the environment cleaner. This is my friend Mags.
Hi,
Mags. Mags is a huge advocate for animals. And because you're always looking for products that are eco and animal friendly, I thought you'd be interested in some of these things.
I am.
Well, all right. Greg and I are trying to get the chemicals out of our house and ultimately the environment. And we thought one great way to do it was to start with alternative and more natural cleaning methods.
Yep, I've actually already did that. I
Right.
buy it at the store.
Which you can too, right?
Great products, biodegradable, not tested on animals.
That's great.
You know.
And I'm glad you brought this because I wanted to try it. You told me about this last time. And
yeah, you should.
Yeah.
But I'm sure your stuff is great.
Well, I got a natural cleaning recipe book, and I've been trying it for the past few weeks, and I really, really love it. This is water, vinegar, and baking soda. The baking soda and vinegar, I guess, have the real cleaning agents, but I added a couple of drops of essential oil.
Oh, that's a great idea.
Yeah, because I also read that they have a disinfectant quality as well.
And they smell good.
And they smell good.
Yeah, that's great.
So it's just a couple drops. Really seems to work. This is the same thing, except it has borax instead of baking soda. Borax, also a disinfectant. But I use this in the bathrooms because you're not supposed to use it around food, is what I heard.
Okay,
So anyway, I'm
okay.
experimenting, you know.
Sure.
Bathroom, kitchen, works great. Oh, this one has a little orange oil.
Oh,
actually,
that's such a
in it.
great idea.
Yeah, I'm telling you. And this is just the water and vinegar, the age-old, right?
Absolutely. I've used it. It works wonderful, and you can't get any cheaper than that.
No, you really can't.
Nope.
Windows, right? Mirrors.
No,
It's
I don't
fantastic.
know why you'd buy the.
Well, I
buy
thought-
it. I mean, it's
Yeah.
inexpensive enough, but that.
That's right. Yeah, absolutely. But this I wanted to try for some of the laundry products and everything.
Yeah. Oh,
Right?
sure.
Yeah. And I think you're really going to dig this.
Okay.
All natural flea and mosquito repellent.
That's great. I'm always looking for. I honestly,
Absolutely.
look the stores for anything that's not going to harm the dogs. You
Right.
know, I don't want to put chemicals on them.
I know, absolutely. Or on us.
Yeah, sure.
You know, because Mags and I have 3 dogs, both of us, and we're always hugging them
Yeah.
and petting them. They're up on the furniture,
Right.
so we're exposing ourselves to those flea toxins as well. You know, the toxins we use
Yes.
to fight them.
Yes.
So
And they're not cheap.
they're not cheap.
Yeah.
Absolutely not cheap. And I haven't tried this yet, but it's water with some lavender oil and some tea tree oil. Just a
sounds
few
great.
drops. Don't need a lot.
That sounds great.
I don't know if it works yet.
Okay.
But check our website because we're going to keep a running tab of how these things work.
Yeah.
You know, on the dogs and on
I
us
can't wait to
because
try
they're
it.
also, mosquito repellents and stuff. Yeah. So we'll give it a shot. All these things over here, they're cheap. Obviously, they're effective. So far as we know, we'll try this, and they are better for the planet and essentially non-toxic. But of course, you still don't want anybody to drink them. So keep them away from kids and animals. Essential oils can be harmful if ingested in large quantities. These are just a few drops. You don't have to spend a lot. And if you're just cognizant of it and you think about it, you can find these products.
Sure.
You want to help me clean?
Yeah.
Yeah?
I can't wait.
Come on. Let's go. Oh, got it. So in summary, everyone can start living a healthier home life right now. More natural versions of cleaning products, insect repellents, even candles and air fresheners are better choices because they use the Earth's more natural rhythms.
Thanks for joining us Newly Greens on another episode of Green by Design TV. And thanks to BASF Corporation for sharing their pioneering efforts at their Better Home, Better Planet initiative and the Near Zero Home.
Yep. And thanks to Damon and Mags for helping us get green and clean. And you know what? Always treat your friends to a nice glass of organic wine after a long day of work too.
Hey, and let them share in your doggies.
That's right.
Feel free to stop by our website and let us know what you're up to if you're doing anything green or if you have any questions. And you can get more information about everything we've talked about. So until the next time, keep thinking green.
It's good for the earth and it's good for you. Cheers.
Cheers.
Guys.
Cheers, Bailey.